All right, you should have been given a picture of Earth's currents in their ocean. We're going to take a red and blue, in your case pencil, and we're going to trace the warm waters of the ocean and the cooler waters of the ocean, and see how they play a part in the ocean's currents. So you'll need a red and a blue. So I'm trying to find my blue. All right. All right. As you would expect with convection, colder air is more dense. Remember, the atoms come together and they tend to pack together when things are cold. So that increases the density. And as things become more dense, they tend to sink down, right? Think about wind. Hot air rises, right? Like a hot air balloon. Hot air becomes less dense. The atoms move away from one another and air rises. And then the cooler, more dense air kind of sinks in, causing that convection current. Well, the same thing happens in water. We have here the North Pole and we have the South Pole, and we would expect there that the waters would be cold. So those waters are going to sink down towards the equator. So if you'll use your blue pencil to go over these cold water areas, and then at the South Pole, if you'll notice the South Pole here, these waters kind of travel across the globe. But if you think about it, if you notice where most of the land masses are on our Earth, right, they tend to be, we have more land in the northern hemisphere, so that land causes changes in surface water, right? As the current is flowing and it hits a continent, it tends to change its direction. So that's why we see this difference here in the southern hemisphere versus the northern hemisphere. We don't quite have that movement of that cold air. That cold water. All right, so our dense water here, and then this area here, right, is called the equator. We've said that word a lot. What happens here, if you were to shine a flashlight on a globe, you would find that here at the center part of the Earth, the sun's energy is most intense. So that's where we have our warm air and our warm waters. So that's where we're going to expect to see our currents becoming less dense and rising up. And then that cold water is going to fill in and cause that deep ocean current. So these are deep ocean currents. So in that beginning of that video, it talked about how the boat that had all the rubber ducks, sank, and they found rubber ducks all over the place. Well, this is why there's a deep ocean movement of warm water and cold water. As you saw in the demonstration of convection in that aquarium, you saw that warm water rise up and that cold water sink in, and you saw it mixing. Well, that's what happens on Earth. So you'll notice here along the equator, that's where our warm water is, and that's where we really have that warm water rising up towards the poles and moving. So you might see a question like this on the star, as far as they might give you a map like this, and they might say, well, what happens if I live in Florida and I put a message in a bottle, where would the bottle end up? And it might give you different places on the map where you might predict. So you would just trace those currents and pick a place on that map. They're probably going to give you one that's correct, and then the other ones are going to be on other sides of land masses or something. So that's a very strong possibility of a question that you might get. So you need to understand how these warm water currents change the direction and movement of our oceans. All right, so once you get your ocean currents copied like this, you're going to glue this in your journal. All right, thank you very much.